but I found the auto start feature.
All righty. Hello, guys, gals, and non-binary pals. My name is Jasmine. I'm coming to you live from the Michigan Science Center, and I'm here today to share a program with you we call Amazing Astronomy and Fantastic Physics. Oh, glad I got that figured out. Now we can get back to our program. So if you're joining us in Zoom or on YouTube, however you're joining me today, there is a way to interact with all of our features and to chat with me during the show. So to start off our Amazing Astronomy, Fantastic Physics show, I have a question for you all. And my question is, have you ever been to the Science Center, or maybe you've just looked up in the nighttime sky? If you were to go into the nighttime sky and look out into the world, what would you see? So this is a great time for you to use those chat features and interact with me and tell me your answers. Don't worry, I will keep a close eye to see if anyone is chatting with me. So remember, the question is, if we go and look out into the nighttime sky, what do we see? Let's see. Now, I've got a few ideas myself of what I see when I look out into the sky. I know that if I look out into the nighttime sky, I would see lots of stars. I could also point out maybe a couple of constellations. Maybe you would see the moon. What else? Let's see. Well, maybe you would also see some planets. And so we can see all of those different bodies because they are within our solar system. But our solar system and space, that's not all there is, right? Our solar system doesn't take up all of space. There are about 100 billion galaxies inside of space. And to explain to you how expansive and non-stopping of growing the universe is, I've got a little presentation. It's with this balloon. Now, let me explain. On our balloon, I've got these little dots, and each dot represents a galaxy. So I'm going to simulate how space is constantly expanding by putting air inside of this balloon. And I want you all to tell me in the chat, what do you think these galaxies are going to be doing? That took some good arm strength right there. Can anyone see what's happening on my balloon? Maybe if we get a better close-up. There we go. So maybe we can see what's happening to all of these dots on our balloon. Let's give it a little bit more air. Ooh. There we go. So if we look around at all of our galaxies, what do you see happening? Well, you've probably noticed that all of these galaxies are starting to get farther apart from each other. That's right. They will continue to spread out and expand forever and ever because space has no edge, and it will continue to infinitely grow forever. And that's why it's so awesome when scientists can work together to go out into space and figure out the things that we don't know yet. Let's go ahead and get rid of this balloon. So that's what space, well, that's how expansive space is. But what's it like to actually be in space? Well, I've got another thing to show you. We like to say that space is a vacuum. This means that space is devoid of all matter, including air. Now, we have a lot of air down here on Earth, right? We actually experience a lot of air pressure pushing down on us. It's about 15 pounds on every square inch of your body. Now, are any of you feeling particularly tired every day whenever you feel all of that air pressure pushing down on you? Ooh, maybe it's older folks. I think I just hurt my back. So maybe we don't feel the strength of air pressure every day, but that's because we have air pressure inside of us as well. And all of the air inside of us is pushing out at an equal force. But what would happen if we were to go into space without a spacesuit? How would the air change? So to explain that one, oh, that's a question that you can answer inside of our chat feature. I would love to interact with you all and get what you guys ideas about space. I'm sorry, I'm just so excited. I'm all over the place. But go ahead and answer in the chat. What do you think would happen if we went up into space without a spacesuit? Well, I get this next demonstration ready. Uh-huh. All righty. So since space is devoid of all matter, including air, we call space a vacuum. And so right here, I've got an example of a vacuum. And instead of using a real person, because that would be very hard to do inside of here and a little bit dangerous if I say so myself, I've got this nice balloon. Now, this balloon is also filled with air, as you can see. And I'm going to hook him up to our vacuum. And let's see if we have any guesses on what would happen. There we go. Let's see if we have any guesses on what would happen to our balloon once we take out the air around him, or maybe what it would be like in space without a spacesuit. All righty. So, well, it's time we figure it out, huh? Scientists love doing experiments, and I'm hoping you're here seeing this with me. So, we've got our balloon right inside of here. Oh, let me see if I can jiggle him around for the show. There we go. All right. So, ooh, maybe a zoom in. All right. So I'm going to turn on our vacuum pump and we're going to see what happens to our balloon once I take the air from around it. Whoa. So did any of you guess correctly what would happen with our balloon? I'm sure you noticed what happened. It got much bigger. Now, the reason this is so much bigger than before is because remember that air pressure we were talking about that's pushing down on us right now? Well, I used the vacuum to take out all of that air on the outside. And remember how I said that there's air pressure inside of us pushing out? Well, since there was no air pressure on the outside to keep it down, all of the air inside of the balloon continued to expand. So if we were to go up into space without a spacesuit, all of the air inside of our body would also expand into poof. And that's what I call a very bad day. That's why spacesuits are so important. And now for the fun part of this experiment, we gotta let the air back in. Very nice. So now that we know what it would be like in space, and we know that space is called a vacuum, the next question is, how do we get into space? Well, that's where physics comes into play. Now, I know physics sometimes seems a little bit daunting, but I consider physics to be an explanation on why things move the way they do and using math to explain how they move those ways. Now, don't worry, we're not going to be breaking out any calculators for this. For this example of physics and how we get rockets into the sky, we're just going to talk about a guy named Isaac Newton. Now, you all may have heard of Isaac Newton before. He came up with 3 laws of motion that explain how things move down here on Earth. And one of those laws that we're going to talk about says that for every action, there is an equal and opposite reaction. And it is this law that explains how we get up into space. Now, a good way to demonstrate this at home is if you just take your hand and you knock against the floor, you knock against the table. After you knock on the table, or as you're knocking on the table, you'll probably notice that your hand starts to hurt a little bit, right? And that's because of that equal and opposite reaction. As you are pushing down on the table, that table is pushing back up at you. And that's why it starts to hurt after a little bit, especially if you knock on a door too hard. That equal and opposite reaction will be there to remind you. Now, instead of knocking on the table, we're going to do another experiment together, and this one involves some safety. So let me get this set up. Da, da, da. Da, da, da. Da, da, da. One more thing. There we go. Safety first, friends. So, for this equal and opposite reaction, we are going to simulate a rocket launching off. And so I'm going to use this ping pong ball launcher. So what I've got to make this work, we're going to use something called a combustion reaction. And a combustion reaction needs three things in order to happen. It needs fuel, heat, and oxygen. Now I've got those three components right over here, but I want to take a little bit of time to tell you that this is not safe to do at home. I'm a trained professional who has done this demo lots of times, and I'm taking every safety precaution I have to keep myself safe, including a nice little fire extinguisher in case anything goes wrong. So remember, don't try this at home, but maybe if this was really cool to watch, we can do it a couple times and then you can just rewind it later. So I've got this nice little launcher, if you will, and inside of it, I've got a little piece of flint. This is going to be our heat source. I've got our fuel source right here, and we have air all around us. So this should be a pretty good equal and opposite reaction. So the first thing I'm going to do is add a little bit of fuel. There we go. Inside of our launcher. Gonna get it to coat the area. There we go. And of course, we have to have something for it to push back out against. So, gonna have this little ping pong ball. Just gonna yeah, there we go. All right. So now I've got my ping pong ball inside of my launcher. I'm going to give this a twist and tell me what you think is going to happen. Remember, we're talking about that equal and opposite reaction. So there's a combustion reaction that's going to happen inside of here, and there's a ball right here on the outside. So what do you think is going to happen? All right. Time to try it out and see, right? In 3, 2, 1. I bet you guys guessed that correctly as well. We were going to have that ping pong ball shoot right across the room. It went pretty far, but don't worry. I've got another one. Ta-da! Let's get a little more air in here. And we'll see that equal and opposite reaction one more time as it pushes against our ping pong ball. All right, let's see. Ready? 3, 2, 1. That was so awesome, right? So we saw that equal and opposite reaction. Push that ball, shoot it across the room, and that's the same phenomena that happens when we put rockets into the sky. So that combustion reaction is happening at the bottom of the spacecraft. And instead of letting it all out at once, you might remember that 3, 2, 1 launch that you hear. So once they launch, all of that combustion reaction that's been building in the bottom of the craft is released poof, all at once. And that equal and opposite reaction pushes down against the ground and shoots the aircraft into space. Thank you, Isaac Newton, for explaining that law for us. So now that we know how rockets get up into space, what about how they continue moving? So to explain this one, we're going to look at another one of Newton's laws of motion, and this one talks about inertia. Now, inertia is the property of an object to continue moving in motion unless acted upon by an outside force, like, say, hitting a mime wall. Poof. Ooh. Likewise, an object at rest will stay at rest unless acted upon by an outside force. And the way that I can explain this is with this little cup of beads. Now, inside of here, I've painstakingly twirled lots and lots of beads because I want to show you how energy moves, right? And so there's a lot of stored energy inside of this cup. and we call stored energy potential energy. Now, if I were to share some of my energy with these beads, they would have a little bit of kinetic energy, or the energy of motion. Now, these beads, using Newton's laws, says that if I were to stop moving these beads, that these beads should stay right here over the table still. It's gonna be my magic trick. Are you ready? Well, that didn't work. Maybe I should switch back to my fancy glasses. There we go. All right. So Newton's law says that an object at rest will stay at rest. So that means that these beads should stay here above the table when I let go. Ready? Whoa. Well, they didn't stay above the table. Well, because something else pulled them down. If I didn't pull them down, there has to be another force acting on them. Okay, well, that doesn't really make it. What happened to my beads? If I wasn't the one who pulled out all the beads, they were at rest, right? But remember that the law, it says that an object at rest will stay at rest unless acted upon by an outside force. And since I wasn't the force that pulled it out, there's got to be a much larger force at hand. Does anybody know what that force is called? It's the one that's pulling all of us down to the ground right now. I'll give you a hint. Starts with a G, ends with a Y, rhymes with lavity. It's gravity. So gravity was the force that pulled all those beads down to the ground. And something called inertia is what kept those beads following, because that object in motion will stay in motion all the way down to the floor. So once that rocket takes off, it continues to use all of that energy as it goes up into the sky. Again, thank you, Isaac Newton, because now we can explain these awesome, kick that over here, these awesome properties of getting into space. Now, one of the cool reasons we like to explore space is because different planets have different extreme weather events that we can see happening, even from this far away down here on Earth. And the last thing I want to share with you all is an extreme weather event as well. Now, studio's a little small to do my original thought, but I've got a good second one. And I hope you're excited because we are going to do a vortex cannon. That's right, we're going to create a little mini tornado right inside this box. Now, to help me do this, I do have a cannon with me. I didn't ask her, are you ready? Are you ready? I'm ready. Ta-da! So this is our vortex cannon, and this is really good at launching air. Now, I know you're like, Jasmine, how do you launch air? It's not a solid. You can't just take it and throw it. Well, this right here can, because this can, because it's a trash can, the trash can. All right, so we're together now. So at the bottom of my cannon, I have a nice sheet of plastic, and this sheet of plastic is going to push all the air molecules against each other and shoot them out. It's kind of going to be like a traffic jam, and it's going to poof, 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 including that sound effect. So if I were to hit the bottom of this cannon, you probably heard the sound, but of course you didn't feel anything, right? We're talking between computers. Now, don't worry. I said I wanted to show you an awesome extreme weather event. And of course, that didn't work. So I've got a way to help us out. And it's with a little bit of fog. So I am going to fill our cannon with some fog. so we can see how this air travels. There we go. Ready? Whoa. So we can see our cannon is pushing out the air. But now we can see with our fog that it is pushing out in these awesome little rings. And this is what we would call a vortex. Very nice. Now, if you also want to do a vortex cannon at home, you for sure can. Maybe not with a trash can. That was rather large. But if you have a fog machine and it's getting close to Halloween time, so maybe you should get your parents to get you a fog machine. You can also use a plastic cup, cut the hole out of the bottom, and then attach plastic on one side, and poof, you have a vortex. So that is going to be it for our show today. And what did we go over? Well, space is a huge, expansive place. And the way that we get into space is using different laws of physics. And exploring space will happen forever, friends, because there are so many answers that we don't have. And it's so fun and important that we share that information with each other. And I hope that you all, well, I know that you all will be the next series of astronauts and scientists and physicists and mathematicians to go out and share more with what we know about our world. So let me check and see if there are any questions before we get out of here. All right. Well, with that being said, thank you so much for letting me join you today. And we, or I, well, all of us here at the Michigan Science Center will see you next time. Bye-bye.